In this final segment on inheritance, we'll compare composition and inheritance. But first, I want to talk about when we would want to use private or protected inheritance. So as we had mentioned before, when you use public inheritance, you want it to be known that the object that is being derived is a type of that base class object. So for example, we saw that a student is a person, so that's public inheritance. When we want to use private or protected inheritance is when we have an as-a relationship or implemented in terms of. And in particular, we can think of list as one of those cases in which private or protected inheritance makes sense. So here, suppose we have a class list and it has the public interface for insert, size, get, pop. Now, we know that a queue is a specialized type of list. In particular, it has a protocol, which is first in, first out. So with the queue, we don't want to be able to insert anywhere in the queue. So we want to figure out how we can prevent direct access to, for example, the entire list public interface, or in particular, insert, because when you have a queue, you can't just insert at any position that you want. So in order to do that, we can use private or protected inheritance. And what this does now is it permits the queue class to call the functions from lists explicitly, but any time an object of the queue class is instantiated, you cannot call the underlying list functions, the public interface, directly. So this is an example of when we would want to use private or protected inheritance, is when you want to implement the derived class in terms of or as a list. You want to be able to benefit from using all of the list functions that are already implemented for you, and basically the derived class will just be a wrapper around the private or protected list class. So in this specific example, you can see that push back, we can only put an item in the list at the end of the list. So we just put a wrapper around the insert at the end of the list. So insert size, a specific value, will put a value only at the end. And then for pop front, we can just only get the first element of the list. So this is how we can implement this first in, first out. We have to put items in the back of the list and remove them in the front of the list, as we would, for example, in a queue if you were waiting at the supermarket or something like that. So this is an example of when we would want to inherit using private or protected inheritance. Okay. This can also be accomplished using composition. So composition is not inheritance. It is a has-a relationship. When we use composition, you'll notice that the class that we're using for the actual implementation is a member. And here is the composition right here. So I just want to highlight this for you. We make a list object a private data member. You'll notice that there's no inheritance here. So this is, just want to make sure we make this clear. There is no inheritance. There is no inheritance anywhere. This is composition. So when you make the list class the private data, or whatever you want to use for the implementation as the private data member, that is a has-a relationship. So composition, this is where composition comes in. And then you'll notice that the functions for the queue are still basically wrappers for the public interface for lists. But in this case, you'll notice that here, we just have to make sure we access the public function on our data member object. So we have to call myListInsert here, or myList pop. But you'll notice that these functions are still doing the exact same thing. They are only adding items to the back of the queue and removing them from the front of the queue. But you'll notice that the difference is twofold. One, we have to have a data member, which is the class that we're going to be using for the composition and for the implementation. And then you have to actually access the public interface of that class using the data member object. So in this specific example, our composition is using a list as the private data member. It is called, that data member is called myList. If I want to call any functions of the list public interface, I have to access it through the data member object myList. So we have mylist.pop. And that is how we can access the public interface of the data member. Some advise that it's preferable to use composition rather than inheritance. It does take some discernment in order to decide, and some of this is a deeper conversation that you would have, for example, with other people and team if you were developing a software system, where you would have to figure out which classes would actually be subtypes of other classes and make the case for inheritance, or when it would make more sense to use composition the way that we've just illustrated here. So there's no easy rules for this, that it usually takes quite a bit of data modeling and experience to make that decision when it's wiser to use inheritance versus composition. Okay, one final warning that I wanted to give you is multiple inheritance. So C++ actually does permit multiple inheritance, but unfortunately, it is not elegant, as you might have seen in Java, for example. So you may have seen with inheritance, you can inherit from a class and then say it implements the interface. Well, C++ will allow you to have this multiple inheritance, but it can create a situation, as we've shown here, which is known as the diamond of dread. So if we're not careful with multiple inheritance in C++, so you see we have this animal class, and it has a weight, public weight function, and private data members, that's the weight. And then we inherit publicly animal to create our new tiger class, and we inherit publicly animal to get our lion class. And then we think we're being clever, so we are going to create our liger object, which inherits publicly from tiger and lion. But what happens is that because tiger inherits from animal, tigers have a weight. Because lions inherit from animal, lions have a weight. So then we create this liger object, and it has two weights. It has a tiger weight and a lion weight. So now suppose in main we instantiate our liger object and we try to get the weight. This won't compile, and the reason why it won't compile, it's ambiguous. The compiler doesn't know which weight you need. So there's two fixes for this. There's one, you can use the scoping operator. So for example, if I want to get the tiger weight, I would just use the scoping operator to indicate tiger and call the get weight. So this would actually give me whatever the tiger get weight function is. Another fix, and if you use the scoping operator with lion, it would have the same effect. So that would actually compile. Another solution is you can actually use the virtual keyword before the inheritance. And when you use the virtual keyword, the liger class will only have one weight. So this is two different ways around this problem, but the deeper takeaway is be judicious in multiple inheritance, that it's absolutely necessary, and that you are not creating this diamond of dread, as it is referred to. So this is an example of how multiple inheritance will not work very elegantly in C++ if it's not used judiciously. And that was some of also the warning about composition versus inheritance, is that we want to make sure that we're using inheritance judiciously when we're actually using it for subtype behavior, or proper subtype that is extending or making the behavior of the base class more specific. Okay, now just to wrap up, we talked about 3 different types of inheritance. So we talked about public inheritance, and is a relationship. And as I mentioned, we do that specifically when we want to specify a class that is a proper subtype and we want to give more specialized behavior to it or adding extra behavior for it. So that's is a public inheritance relationship. Then we talked about protected and private inheritance. And that is an as a relationship or implemented as or implemented in terms of. And we want to use private or protected inheritance. We want to take the benefit of the base class, so all of the functions of the base class, and protect it. We want to hide the fact that we are using the public and protected data members and functions of the base class. So that's the example that we did with the using the protected or private inheritance for the queue, because the queue is a list with a very specific access protocol, which is first in, first out. An alternative to private or protected inheritance that may be more appropriate sometimes, or many times, as some might argue, is composition. Composition is not inheritance, it is a has a relationship, and composition is when you compose your class of other classes. So you include the other objects of other classes as data members rather than using inheritance. So many times composition may be quite helpful for you. And this is specifically what we have here. We have this example of a queue class implemented using composition, where we are using a private data member, which is the list class. And so when you use composition and the private access within the class, so you're protecting the underlying public interface for the list class, doing it that way. So that's how you can use composition also to create classes when you want to hide the implementation details, and that's part of encapsulation. So these are something that you'll get more comfortable with experience, but right now we just wanted to summarize the different types of inheritance that are available to you, and to get you thinking about when you might want to use public inheritance versus private inheritance or composition.